The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the total population uses. And for this, we need, of course, the Sun, which is the most abundant source of energy, and silicon, which is the second most abundant element on the planet Earth. But why do we need silicon? Greetings everyone, I'm Tanisha from 10th B, and I'll be presenting my model and explaining the working of a solar panel. And when I talked about silicon, it was because each solar cell in the solar panels are made of silicon. Each cell has two layers, the N-type doping and the P-type doping, both on top of the other. The N-type doping has free electrons, while the P-type doping has free empty spaces. And at the junction where they join is also known as p-n junction. Now near the joining area, free electrons from the N-type move towards the P-type to fill the empty spaces. Thus, a depletion area is created which is neutral. Due to this movement, the N-type becomes slightly positive, while the P-type becomes slightly negative. When light from the sun strikes the top layer, it penetrates through the N-type doping and reaches a neutral region. The energy from the photons breaks the bonds and creates many electron and empty space pairs in this region. Due to the electric field, these are driven out, and the concentration of electrons in the N region and empty spaces in the P region becomes so high that a potential difference is developed. As soon as we connect any load between them, the electrons start flowing through the load. The electrons recombine in the empty spaces in the P region after completing their path. In this way, a solar cell continuously gives direct current. But this was only about a single cell, which can only produce a voltage of 0.5. That is why a series of them are connected to provide a usable energy. To give you an idea, 12 PV cells are enough to charge a cell phone. And since my model has 12 PV cells, you can try that using my model if you can. Thank you.